Hey everybody, I'm Gale Banks. I'm a curious guy. I look at these diff covers and I go, what are they doing? What value are they? Are they correcting something? Because I look at the ads and there's no talk about temperature or fuel economy due to drag in the axle housing. There's nothing whatsoever. So are they just bling, or are they really doing something? I wanted to know, first of all, what trucks are we dealing with on this American axle 11.5? There's also an 11.8 optional ring gear dimension that fits in the same housing. The covers, the axles are in GM, that being Chevy and GMC trucks, Dodge trucks, and the later ones being called Rams. The first application is 2001, and they come all the way up to date. Same bolt pattern, same ring gear diameters. I wanted to know the dynamic running level in the housing. I wanted to know how hot does it get when you climb the mountain. I'm curious as hell. So I came up with a scheme, worked with the guys to sight gauge the stock diff cover, run it on the dyno with airflow under the truck that it was equivalent to 60 miles an hour on the street. I figure if you're towing up the mountain and you've got a hellacious load out back, you're probably 60 miles an hour, maybe a little faster. We started out with filling to the stock specified fill level per the owner's manuals. And we looked all the way back to 01 and all the way up to current 2018. GM, with the same axle, calls out a different fill level than the Chrysler guys call out. I've done a lot of powertrain design in my career, and I know that there is a design running level for the lubricant in this axle. That's the sweet spot. Not too much, which can cause additional aeration because you're burying the ring and pinion in lube higher than it's designed to be. As a result, you'll be doing more work, but you might be heating the oil more by burying the ring and pinion than by having it at the design or proper level. If that's the case, and you add more capacity, or you raise the height of the fill and add more capacity, you're guaranteed to bury the ring and pinion. I just want to know, by fingerprinting the stock setup, so we did it on our old 6.7 here, this is about an 08, this is our shop truck, and it's real good for running sustained on the dyno because it's dual, so it holds the tire temperature down. You can run a long time. So we put sight tubes on the stock diff. We put it on the dyno. We set up our 40,000 CFM blower to nose load the truck with 60 mile an hour air, and we side skirted the truck so it kept the air under the truck and at the correct velocity as if you're on the highway. Now, how do we know what that correct velocity is? Well, we put an anemometer on the truck. We ran it to our iDash data logger, which is our gauge with the micro SD card in it, and went out on the road and data logged the velocity. We found that there's a dead area behind the axle. If you think in terms of aerodynamics, and you've got a flat ass end on the cover here, the air does not flow around it and then come together nicely. So you've got this low pressure fingerprint. That's what we were checking here. We also put this in front of the axle, so we got the velocity in front and the velocity behind. This is a tell. If the design amps up the velocity here, it's going to cool better. We ran the stock setup. We found how much it dropped from the fill level to the run level in the stock axle. Where's the lube level when you're running? that becomes the benchmark. That's the designed lube level. It'll be a little different with a GM because those guys chose a different height. They may have a different stock pinion angle, which rocks the cover and the input. So it rotates around the axle shaft when you change the pinion angle. I know we've got vehicles we're working on right now with the L5P where the pinion angle is 3 degrees on one vehicle and 6 on the other. One's a military vehicle, one's a production vehicle. So here, the installed pinion angle is what we're designing to. We're going to stay with that. If a guy jacks with a pinion angle, we'll have a discussion about that later. So we ran the stock. It's quite a drop to the run level. Now we're instrumenting the aftermarket piece. We measured the temperature on the stock. We ran 200 horsepower continuous, like you're just pulling this mountain forever. And with the airflow cooling as it would on the street, and we hit a peak of 336 degrees. Well, I'm going to tell you, it's hard to find data about where the peak should be, but we're running 75 W90 synthetic. Synthetics vary quite a bit. We've got a lot of data, we've done a lot of research. We put Eric Ryder on that, and he came back with the performance for various makes of lubricant. We chose one make of lubricant, and we'll be using it for all the testing, so that's fixed. The test vehicle is going to be this Dodge, and next will be a GM product. So we're going to run both of those. At the end of the day, you want the minimum temperature of the lubricant to get beyond the dew point temperature on that day. That ensures that you're getting water, condensate, out of the axle housing through the vent. So the last thing that's in the back of my mind, there's flywheel horsepower and there's road horsepower. And all of us already know the flywheel horsepower doesn't get to the road. Why is that? Parasitic losses, frictional losses, and what's called viscous losses. Viscous losses has to do with adding heat to the lubricant. It happens in the gearbox, it happens somewhat in the U-joints, it certainly happens here in all the bearings, etc. That frictional loss uses some of the horsepower. Viscous loss uses some of the horsepower. If we increase the viscous loss due to overfilling the rear axle, I expect we're going to lose miles per gallon. We want to optimize miles per gallon by diminishing drivetrain losses, not by increasing them. So that's a big deal in this. We're going to learn a lot on this testing. I'm going to learn a lot because I don't know a lot about this. But boy, are we going to put some information out there. And ultimately, we're going to answer the question. These things are 275, 300 or more on the internet. Are they doing a positive thing or are they doing a negative thing? We don't know. I know this, if you overfill and overcapacity, when you run, you won't even probably drop to the stock fill level. You will bury the ring and pinion in lubricant. And my experience is that is going to cause it to over-temp quicker. And we'll prove this or disprove it. But I theorize you're going to have quicker elevation in temperature and quicker degradation of more lubricant that you spent more money for. And I don't think that's the goal here. But since no one's ever done this, no one's ever done it scientific, Banks is going to do it. And we're going to put it out there in a way we're showing you everything. You can test it yourself. Our competitors can test it themselves. And in fact, we'll probably end up schooling a whole bunch of those cats. To be continued.